Hello, ladies and gentlemen, and welcome back. Continuing in with the energy unit, we're going to talk a little bit about the greenhouse effect. The greenhouse effect can also be symbolized as GHE. Sometimes we'll see it spelled out that way, the little acronym for it. Sometimes just greenhouse effect. Either way, you'll be familiar with it. The greenhouse effect is extremely important for Earth. It really helps the Earth regulate its temperatures. But if you've listened to the news lately, you'll hear it's also a little bit of a problem. So it's a little bit of a double-edged sword, and we're going to go into some of the problems and how the greenhouse effect works. Greenhouse effect has to do with insolation. Remember, I said that this would be coming up quite a bit. Here it is again. Insolation, incoming solar radiation, energy coming in from the sun, is mostly going to be short wave radiation. That is a part of the electromagnetic spectrum. What we're going to be looking at mostly is visible light and UV or ultraviolet radiation. These are the two biggest ones. Remember, the sun also does give out a little bit of infrared radiation, but these two right here, visible light and UV, are the ones that we're really concerned with, and they're coming in as short wave radiation. So sometimes you'll see me sloppily just kind of scramble it onto there, but you see just the waves there, and it's going to be shorter wave. The greenhouse effect has to do with visible light coming in from the sun. There we go. Let's use blue here. As short wave radiation. So you can see it here, short wave radiation coming in. And what happens is it gets into the Earth. The Earth then absorbs this energy. When it absorbs it, it re-radiates some out as infrared or long wave radiation. And what happens is as that gets re-radiated out, there's gases in our atmosphere that are going to cause that for some to get absorbed and then also bounced back or trapped within inside the Earth's atmosphere. So the greenhouse effect works like a greenhouse. Greenhouses usually are made up of many glass windows or a plastic material that will allow this UV radiation to come in, or visible light, short wave. What happens is inside the greenhouse, that energy is absorbed by the materials in it, the plants in it. They radiate it out as long wave, like this, and the greenhouse itself will trap the energy. So the analogy between the greenhouse effect as far as the Earth and greenhouses, basically the only difference is how that energy is trapped. Within our Earth, it's gases. Within a greenhouse, it's the actual material or the glass itself. So the greenhouse effect for Earth is a rise in temperature that is experienced because certain gases in our atmosphere, and these are important to know: water vapor, carbon dioxide, nitrous oxide, and methane. These greenhouse gases, or GHG, they trap energy that was radiated out from the Earth. Water vapor, H2O, vapor, carbon dioxide, CO2. Nitrous oxide, sometimes we'll also see it as NOx. There's different forms, other compounds, nitrogen compounds besides nitrous oxide that act as greenhouse gases, and methane, CH4. Okay, I would be more familiar with these right here, but occasionally you'll see me write them like this also, so just have it in the back of your head that what I'm writing are greenhouse gases, and they're trapping energy that's radiated out from the Earth, long wave radiation. Interestingly enough, if we did not have the greenhouse effect, the Earth's temperature would be on average about 60 degrees Fahrenheit colder. So the greenhouse effect is an extremely important process that happens on the Earth to help regulate its temperature and keep it really livable for us. If it wasn't for that, things would be a lot colder and definitely a lot different than what we see now. Okay, here's a greenhouse right here. And remember, like I said before, really the only difference between an actual greenhouse and the greenhouse effect that happens on Earth is the material that traps that energy. So here we have the glass that traps that long wave energy. Here on Earth, it would be the actual gases, greenhouse gases in the atmosphere itself. Okay, what causes the greenhouse effect? And here's our gases right here: methane, CH4, nitrous oxide, CFCs, chlorofluorocarbons. Write that one out for you. Chlorofluorocarbons. These are also act as greenhouse gases, and CO2. So there are a lot of different gases out there that can act as greenhouse gases. Okay, sources of carbon dioxide. Really, one of the biggest things is burning of fossil fuels. Probably one of the biggest things that is going to be a generator of greenhouse gases, especially CO2. Burning fossil fuels also release a number of other greenhouse gases into the atmosphere, but CO2, that's our big one, biggest man-made source right there. Okay. The greenhouse effect is not to be confused with the ozone layer. They do have very slight overlap, but for all intents and purposes in this course, there really is not much of an overlap. So they do have a little bit in common. There is some a little bit of information out there on how the ozone and greenhouse effect may work together a little bit, but they are two different things. The ozone layer is a layer of gases, O3, that protects us from that shortwave radiation of UV. So ozone is also O3. And notice here it's located within the stratosphere, and it protects us from UV. So this is stratospheric ozone. Okay, stratospheric ozone, O3, is going to protect us from UV. Pretty important. Remember, UV is short wave radiation. So it has a lot or more energy. So it's very damaging to us. And so you could thank the ozone layer for helping block some of that out and absorb some of it so that it does not affect us down here on Earth. Okay, so some of the sun's energy gets absorbed by this ozone layer. And good thing for that, because like I said, the UV is very harmful to us. And this is one of the reasons why we put sunblock on, wear certain sunglasses, because all that will help take whatever other little bit of UV radiation is coming in and block it from hitting our skin. Okay. There are some other things that happens to sunlight. Clouds, they're going to reflect some of that visible light coming in. Also a little bit of the UV, kind of get blocked out by that too. Aerosols or particulates in the atmosphere, they'll also reflect and scatter some sunlight too. Sometimes we see diagrams coming up like this, or even better, this one right here, that really gives us a comprehensive view of what's happening to the energy that's coming from the sun. So you can see here our incoming solar radiation, insolation, some comes directly down and absorbed by Earth. This right here is going to be leaving as our long wave radiation. Okay, some is scattered by the air, some is reflected off surfaces. So the ice caps or mountains that are light colored or materials that are light colored on Earth are going to reflect some of this right back out into space. Clouds are going to reflect some of that. They'll also absorb some of it and emit it as long wave radiation. So there are a number of things that happens to insolation that comes in from the sun. Okay, and this is looking at just a little bit of a distribution. You can see here 51% of solar radiation is absorbed at the surface. So really that other 50%, there's a lot of things that happen to it. What we mentioned before, some is reflected, scattered, back out into space. Some is absorbed by other gases. So there's a lot that can occur. Okay, and here's just a little diagram showing how or what happens when energy strikes matter. Okay, so it can be absorbed, like we've seen with energy or insolation from the sun. Surfaces will absorb it. Usually dark and rough surfaces will increase absorption of energy. Okay, reflection or bounce off, that's going to be shiny surfaces, light colored. They'll increase the amount reflected. Okay, refraction is going to be bending. This has to do with difference in density. So as, for example, light goes through air and then water, it's refracted. So you can see that if you take a pencil and put it into a glass of water, it looks like the pencil's bent. We all know it's not. Sometimes it gets transmitted, just like through windows, and sometimes scattered. And that's pretty much what happens with insulation that comes in from the sun. Okay, here's an example of refraction right here. Okay, and next up we'll be talking about phases of matter, but that's for another day. Thank you and have a good day.